Today we're going to look at section 2.4a. We're studying lines and linear equations, and our focus today will be on writing an equation for a line that's in point slope form or in standard form. So we're going to start with point slope form. Our equation is y minus y sub 1 equals m times x minus x sub 1. And your m value here, remember, is your slope. And the y sub 1 and x sub 1 come from a specific point that you are given. So for example, let me rewrite that here. You'll be given an x1 and a y1 coordinate. All right, so there are two times when point slope form is very useful. The first is when you are given a slope and 1 point. So for example, it might say write an equation for a line passing through the point negative 1, 3 and has a slope of negative 2/3. So again, slope is our m value, and this point negative 1, 3 is going to be our x sub 1 and our y sub 1 values. So it's just a matter of plugging them into our formula, and our formula, remember, was y minus y sub 1. So we're going to say y minus our y coordinate, which is 3, from here, equals our slope, negative 2/3, times the quantity x minus our x coordinate, which is also a negative 1 here. Now remember, when we subtract a negative, that's the same as adding. So we could simplify this to y minus 3 equals negative 2/3 times x plus 1. Okay, we're going to leave that in point slope form, and now it may ask you to simplify an equation into a different form. So this one is saying simplify the above equation into slope-intercept form. Remember, slope-intercept form looks like this, where our y value is all by itself. So what we're going to have to do with this y minus 3 equals negative 2/3 times x plus 1 is we're going to actually have to distribute that negative 2/3. So we're going to have y minus 3 equals negative 2/3 x minus 2/3 when we distribute that to the 1. And then we're going to get our y by itself, which means we're going to have to add 3 to both sides. So we're going to have y equals negative 2/3 x. And now we have to figure out what this is. So negative 2/3 plus 3 is the same as negative 2/3 plus 9/3. 9 divided by 3 would be the same as 3. And now we have a common denominator, so we can add those together. So 9/3 plus a negative 2/3 would be 7/3. So that would be our y-intercept. And now we have our equation in slope-intercept form. Our next example says, what is an equation for a line that passes through the point 7, negative 1 and has a slope of negative 3? Write it in point slope form and then simplify it to slope-intercept form. So we're going to start out with our y minus y sub 1 equals m times x minus x sub 1. Okay, our point slope form. We are told our slope is negative 3, and we're told that the point is 7, so x minus the 7, and on this side we're going to have y minus our y coordinate. It says to simplify it to slope-intercept form, so we are going to keep going here. Subtracting a negative is the same as adding. We're going to distribute that negative 3, so we get negative 3x plus 21. And now to get y by itself, all we have to do is subtract 1, and we get the equation y equals negative 3x plus 20. All right, looking at our next questions here. It says it's also useful when being given 2 points. That is the second time when point slope form is very useful. If we're given 2 points. Our first step would be to find the slope since we're not given it. And remember, our equation for slope is y2 minus y1 divided by x2 minus x1. We're going to then plug it into our point slope formula and simplify if we're asked to. So our first question here is, what is an equation for a line passing through the point 5, 1 and 7, 9? Leave your equation in point slope form so we don't have to simplify it. So let's go ahead and start by finding our slope. We're going to take the difference of our y coordinates. So y sub 2 minus y sub 1 would be 9 minus 1. We're going to divide by our difference of our x coordinates, so 7 minus 5. So simplifying, we've got 8 divided by 2, or a slope of 4. All right, so now that we have a slope, we can actually use either of our points. So I'm going to pick this one. We could, again, use either one. I'm going to use the 5, 1, and we're going to plug it into our y minus y sub 1 equals our slope times x minus our x sub 1 coordinate. So that would be one possible equation we could have written. If we had picked this point instead, it would have looked like this. Y minus our y coordinate, slope times x minus the x coordinate. So they look very different, but if we actually simplify these down to slope-intercept form, they would look identical. Our next question says, what is an equation for a line passing through the points -5, 0 and 0, 7? We're going to simplify it to slope-intercept form. Okay, so we're going to start out finding our slope. We need to subtract our y coordinates, so 7 minus 0. And on the bottom, in our denominator, we're going to subtract our x coordinates, 0 minus -5. So 7 minus 0 is 7, 0 minus -5 is 5. So we're going to start out with our point slope form. Again, we could use either point, and it says simplify it to slope-intercept form. So let's say we picked the first point. We would have y minus our y coordinate of 0 equals our slope, 7/5, times x minus our x coordinate of -5. Well, y minus 0 is just y, so we're already very close to having this in slope-intercept form. Distributing our 7/5, we'd get 7/5 times x, so mx, and then we have 7/5 times the 5. Remember, again, the subtracting a negative is adding, so this is really x plus 5. When we distribute, we've got 7/5 x plus, and if you remember multiplying 7/5 times a 5, our 5s would cancel out, and we're going to get a 7. So our y-intercept would be 7. All right, the second form that we're going to study today is called standard form, and our equation for standard form looks like this. We have our x's and our y's on the same side, and we have a constant on the other side. The only restriction is that a, b, and c are real numbers, and that a and b cannot both be 0. I'm also going to have you state here that we want them to be integers. So in our steps here to get an equation to standard form, the first step here is to move your x and y terms to the same side away from that constant. And the second step is to multiply to get rid of any fractions in the equation. And we're also going to get rid of any decimals. So we don't want any fractions or decimals left in our equation. So our first question here says y equals 2/5 x minus 3. Our first step is to get our x's and y's on the same side. So I'm going to subtract this 2/5 x to the other side. That's going to give me negative 2/5 x plus the y on that side, and the negative 3 would be left on the other side. Now, to get rid of the fraction in this case, we want to multiply by a 5 so that we can cancel that 5 that's in our denominator. I also like to have our first term being positive So I'm going to actually multiply by a negative 5 so that when we take negative 5 times negative 2/5, we get a positive 2. All right, it's just a little cleaner to have that first term positive. Then distributing to the y, we get negative 5y. And distributing it to the negative 3, over here, negative 5 times negative 3 would be 15. All right, our second example, we're going to have to move this x term over to the other side. I'm going to do that by adding it over. So now I have 3/4 x plus y equals negative 5. And then to get rid of our fractions here, since we have a 4 in the denominator, we're going to multiply everything by 4. 4 times 3/4. Again, your 4's are going to drop out and leave you with 3. So we get 3x. Multiplying it to the y, we get 4y. And multiplying it to our constant, 4 times negative 5 is negative 20. Our third example doesn't have fractions, it has decimals. So we're going to look at what happens there. Step 1 again is to get your x to the other side with y. So we're going to subtract it over. So we'll have negative 9.1x plus y equals a 3.6. Now to clean up decimals, we want to look at how many decimal places we have and multiply by the power of 10. That will clear that up. So in this case, since we just have one decimal spot here, we can multiply by just a 10. Again, I'm going to use a negative 10 to clean up that first term being negative. So negative 10 times negative 9.1 would be 91. Negative 10 times y is negative 10y. And negative 10 times 3.6 would be negative 36. So again, we're cleaning it up so that we don't have any decimals or fractions left. All right, the next part that we're going to look at is to graph equations. And so far, this chapter, we've looked at graphing lines by getting them in slope-intercept form. We don't actually have to do that. If we have it in standard form like this, it's very easy to just find our x and y intercepts. So to find our x and y intercepts, our x-intercept is going to be the value for x when y is 0. And then our y-intercept is going to be the value for y when x is 0. So picture making a little t-chart, and we're going to plug a 0 in for y, we're going to plug a 0 in for x, one at a time. So let's do our x-intercept first. We need to figure out what would go there. So we're going to dump a 0 in for y. We have 4x plus 3 times 0 equals 12. But 3 times 0 is 0, and adding 0 doesn't do anything. So really we have 4x equals 12. Dividing out the 4 would give us x is 3. So my y-intercept is the point 30, and I could go over here and plot that. There's my point 30. I'll use a little darker color here. All right, then to find our y-intercept, we're going to put a 0 in for x. So 4 times 0 plus 3 times y equals 12. 4 times 0 is 0. So 3y equals 12. And dividing out a 3, we'd get y equals 4. So again, plotting that point, 0, 4, we want to go up to the 4 on our y-axis and put a dot. And then it's just a matter of connecting those two dots and making a line. Okay, let's try one more. If you think you know how to do this, you can go ahead and pause the video and try it on your own. All right, let's check here. We're finding x and y intercepts. Again, we're putting in a 0 for each variable one at a time. If we put a 0 in for our y, then the negative 4y drops out, and we have a 2x equals 8, so x would be 4. Plotting that point for 0, we need to move to the 4 on our on our x-axis. To find our y-coordinate, our y-intercept, we're going to put a 0 in for x this time. So now x is gone. And our equation is negative 4y. Don't forget the negative there. Negative 4y equals 8. And when we divide everything by -4, we end up with y equaling -2. So we'll plot that point, 0, -2. And again, then we just have to connect those dots and draw our line. All right, so the thing I want you to focus on is think about which form of your equation you should start with. So far we've had point-slope form, we've had slope-intercept form, and we've had standard form. Our first one says, write the equation of a line that has a slope of -4 and it goes through the point 1/2, 1. Put your answer in standard form. Now just because it says to put your answer in standard form doesn't mean that you have to start with that form. Since we're given a slope of -4 and a point 1/2, 1, makes sense to use point slope form. So we're going to start with y minus y sub 1 equals m times x minus x sub 1. Our slope is -4. And if we look at our x and y coordinates, our y coordinate is a 1 and our x coordinate is a 1/2. Then it says to simplify it to standard form. So we're going to go ahead and distribute the -4. -4 times x. -4 times -1/2 becomes +4/2 or +2. And then standard form, remember, has your x's and y's on one side and your constant on the other. So I'm going to add this 1 over. Right now that's in slope-intercept form. We're going to go ahead and move the 4x to the side with y by adding it over. And we end up with 4x plus y equals 3. And that is in standard form. Our last one says to write the equation for a line through the pair of points 6, 5, and 2, 3. Write in all three forms. Okay, so we're going to start by finding our slope. We need to subtract our y coordinates, so 3 minus 5. And then we're going to subtract our x coordinates. If we did 3 minus 5, we have to do 2 minus 6. And simplifying that, we end up with -2 divided by -4, which is going to simplify even further to just 1/2. So we have our slope now, and we can use either of our points. I'm going to just go ahead and use the first point. So y minus our y coordinate equals our slope, 1/2, times x minus our x coordinate. Okay, so that is in point slope form. Now we're going to simplify that to slope intercept form. So y minus 5, distributing our 1/2, we get 1/2 x. 1/2 times -6 is -3. And then we can add the 5 over, and we end up with y equals 1/2 x plus 2. So this one was point slope. This is going to be slope intercept. And our last one now, we want to convert that to standard form. So I'm going to bring this x piece over with our y coordinate, or our y term here. I'm going to subtract 1/2 x to both sides. So we have -1/2 x plus y equals 2. And then I need to clean up that -1/2 so we don't have the fraction. I'm going to multiply by a -2 to clean that up. -2 times -1/2 x is just x. -2 times y is -2y. And -2 times 2 is -4. And that would be our standard form. Okay, so we've gone from point slope to slope intercept to standard form. We can use any of those depending on what they're asking you to find. So, quick summary. Let's start out with slope-intercept. That looks like y equals mx plus b. Then our new one today was point slope. That's y minus our y coordinate equals our slope times x minus our x coordinate. And then we simplified that to standard form. And that was where we had ax plus by equals c. We had x and y all on the same side. And the last key thing that we looked at today was finding intercepts to help us graph. So think of a t-chart. If you put a 0 in for y, you're finding your x-intercept. And if you put a 0 in for x, you're finding your y-intercept. All right, hope that helps.